Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Felix, why is this logic gate board game prototype laying out here? You know how it makes me feel.
Well, because I was digging through our bins and I thought, you know, we put all that work in there, we could do something with this.
Are you suggesting that
from the ashes of this project, we'll build a better one?
Or at least get some inspiration from it.
Well, Felix, what do you suggest we make?
Maybe you could make something with toggle switches?
Oh yeah, Karen talked about using toggle switches for this to simulate the wires. I didn't think that made a lot of sense because toggle switches are either on or off. But you know what else is on or off? Binary! So I was thinking I could make a decimal, hex, binary kind of electronic quiz game. Like it shows you a number and you have to type it in binary.
Yeah, that could be fun.
Yeah, and it could have like a timer and a beeper and be kind of cool. And what are you gonna do over here?
Almost something sort of similar, having a display, some buttons to represent an abacus.
A digital abacus?
Yes.
All right, and then we're both gonna use microcontrollers, right?
Yeah.
Sounds pretty good. All right, well, let's both get started on our dual project challenge.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
So I'm doing a similar project to Mr. Heckendorn. I'm making an electronic Soroban, which is a Japanese word for abacus. This particular design, I have one right here, it has one row of beads on the top and 4 rows of beads on the bottom. And if you don't know how this abacus works, let me give you a little example. So right here, this would be like your decimal, and then these would be your tenths and your hundredths. So let's say this is your ones column here. 1, 2, 3, 4. So we've just registered 4 beads. We've counted the 4. And we'll unregister these 4 beads and register the upper bead, which is 5. So then there's 5, 6, 7, 8, 9. So we've got 9 now. Let's go to 10. So we will unregister these 4 and unregister this 5 and add 1 of the tens beads. So there's 10 and so on. It'll continue the abacus scale there. So I'm trying to learn the abacus because it's kind of like a really fun tool. I've always wanted to make one electronic because sometimes I'm just kind of sitting around at home and like I can't, when you gotta hold the abacus like completely flat, otherwise the upper beads just fall. And I was thinking ways to do it with beads, however, using switches or Hall effect sensors. Anyway, I just come to the conclusion that I would just use tact switches with LEDs. So I took a little proto board here and made some headers for I'm going to connect an Adafruit 32U4, and the reason I've decided to use this because I have this little breakout board for it, or I think they call them feather wings. This feather wing has a LED driver and 4 alphanumeric displays on it. So I made some headers on this proto board, one with long pins that goes through that will connect to the Adafruit board, and that sits on the bottom. And then on the top we have our alphanumeric display. And I also added some shift registers to drive these LEDs. And these push buttons, these tact switches, are going to represent the beads. See, we have our lower beads and our upper beads. This one's only going to have 4 columns. So what I want to do is when we register a bead, it'll light up an LED, and then also the value of that column will be displayed on this alphanumeric display. And then these momentary toggle switches will be to reset the column so it can go back to 0. So these buttons on here I put into a matrix. I'm gonna have a rechargeable lithium-ion battery pack because this Adafruit featherboard has a battery charger on it, so I can just connect the USB in there and then charge the battery whenever I need to. And then this toggle switch is just on and off, and then that's the reset button.
It's now time to wire up the electronic quiz game. We have 2 sets of shift registers, input shift registers to look at the switches, and output shift registers, which will drive the 3-segment LED display. I'm going to hook up the input shift registers first for the 8 toggle switches, the reset button, and also the 2 mode select switches. Then I will run power and data to the 2 upper shift registers, which will send data out to the LED display. 8 lines for the segments and decimal point, and then 3 lines that select which display is currently being drawn. We draw all 3 very rapidly to get the persistence of vision effect that they're all on, creating a solid display. Now that the unit is all wired up with the battery, it's time to program. All right, I'm going to start programming the Flash Hex game. So hex and decimal, that just changes what the display is. So, you know, either in hex or decimal. So that actually doesn't really affect the logic. Basically, you know, when you go to draw the screen, it's just like, what are you going to draw, hex or decimal? So if we make it a puzzle game, we can randomly generate a number from 0 to 255, and then, you know, if it's displayed in hex or decimal, it doesn't really matter to the system. So I'm thinking that we have two modes. We have game mode and test mode. In test mode, you can set the numbers to whatever you want, you know, like we are right now. But then if you go to game mode and then push start, it will randomly generate a number. Maybe it could be like, it can like change numbers like, and then stop on one, kind of like a roulette wheel. And I was thinking we could use the decimal points as a timer. It could be like beep, 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 beep. So yeah, let's think about the basic logic block diagram of it. Is switch equals game. So if it's no, we just display results, which we have been doing, and then keep checking the switch. Okay, if switch is game, so then it's like game start. So we'll probably have like a variable which indicates the state of the game. So if it's no, keeps checking. Well, there'll be a start button too. So if you push the start button, it'll change the condition of run. So run does not equal 0 acts as our yes to start it. So yeah, I think what we could do is maybe it can just get harder and harder. So we could have a default time, right? So we have a block here which sets up the game. So we call it start game. Default timer set, random seed. I actually don't know if the ATtiny has a random number generator. If it does, it's probably a pseudo random number generator. But what we could maybe do, I don't know if we have one open, but we could possibly use one of the analog input lines to seed a random number. We could hook it up to some external circuitry, basically to have some hysteresis on it to give us kind of a, you know, a jitter value of an analog, and then we could use that to generate a random number. So default timer set, random seed. After that's done, we would go to generate number. Generate random number, start timer. I think there might also be a score reset. Okay, so start timer, like beep, 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 and then basically we'll look at the 8 switches. Do switches match number? If yes, we award points based off timer remain, reduce timer, so it's every time you have less time, ha ha ha, and then generate another random number. So we'll do it just like old school video game. Maybe the first time you have 30 seconds, the next time you have 29 seconds, then 28 seconds. You'll have less and less time. So eventually, no matter what, you'll lose. Okay, so here's the main loop, wall 1. So we're gonna do a little bit of housekeeping here, basically. If there is no audio, make sure it is off. Okay, so if input and game or demo, and we defined game or demo up here as 1 bit shifted 15 to the left, which is the MSB of the input. So basically that's a state. If it's 1, then reset game state and just draw the value of the switches on the LED, which is basically the test mode. That's what we have right here. Turned off the annoying beeps. And if we aren't in that mode, then we're in game mode. And I just have it say 255 there to indicate the difference of state. All right, I did add something else. So game state equals 0. So anytime you're in demo mode, it resets the game state to 0 so that when you switch into game mode, the game will start over. Otherwise, you could interrupt a game and then go back into it, which sounds cool, but it's kind of confusing. And I also added a function of the decimal points. So you do, what did I call that? Timer dot. Well, that's kind of confusing. So you just give timer dot a value of 0 to 2, and it will draw the decimal in that position. So I can just flash this real quick. We can move the decimal point around. I'm just going to use the decimal point for the timer, like beep, 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 beep. So just go faster and faster. All right, so what I'm going to do next is make basically a state machine for that. So I'm going to go down to game here, switch game state. Okay, now we're going to make a bunch of case statements. I would say if you jump into this mode, then game state would at least equal 1. No, not necessarily, because it could be waiting for you to push start. So case 0 is going to be waiting for start to be pressed. We'll call it a tracked mode. Well, I need to think about this a little bit more, but we'll put in at least 3 cases. So what I'll probably do is get the game logic working and then add in the sounds. I might actually make like a really simple like beep music player. Like I might have like, I don't know, 32 bytes of memory that is used for note and time. So you could trigger like beep, 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 a tone to play, but then it'll play automatically. You don't have to sit there and wait in a loop for it to execute. And that would just be called from the main loop here. All right, so I'm gonna flesh out some of this game logic and then we'll just go through it step by step, testing everything to make sure it works on our actual board. Okay, I have a few more of the game states in place. So we have freestyle mode, where you just type in the number, and game mode. See, it's waiting for you to push start. Push start. This is the test of the countdown timer. I'm moving the decimal point with the seconds. And then when it fails, we get that. And then your score, I just temped in 42. And then it goes back to waiting for you to push start again. So what I'm gonna do next is put in the code where it will actually look at the switches and determine if you've got the right number. I think it might be kind of cool, like if you're in hex mode, like if you get one or the other right, it'll flash it, like this number will flash, like, oh, you got that one right, or you got that one right, kind of to give you a clue that you're halfway there. Obviously that doesn't work in decimal, but hey, what are you gonna do? Which means I think I might have to add another function to the thing that draws, basically, which is here. I've already added something called force decimal, because like, what if it's trying to show you your score, but you have it switched to hex mode? I mean, I guess you might want to see your score in hex, but I think it'd be better in decimal. So I'll probably just add something to this, so when you're in hex mode, which is right here, it will flash one digit or the other if it's correct. And then we have a random number generator here. So we get the number, we set the time limit, and then we go into game state. So game state 3 is actually the active state. Right now, it's just doing the timer, but well, actually all I really have to do is say if input equals number, then win. But we'll have to put a few more things in than that. But yeah, making progress.
Okay, so let's go over a review of the code that I wrote for the electronic Soroban. Now this is just plain old Arduino code. However, I'm utilizing the kdevelop program to edit it. So first thing we do is we come in and call our libraries. We're using shift out X, shift pin number, wire, keypad, Adafruit graphics libraries, and then this pitches is an H file that I have here for notes that it will play on the speaker. Of course, I have a version number. Now we need to define the pins for the register. There are 3 shift registers, and these are the pins that are being utilized for it. Then there is a 4x6 key matrix. These are the pins for that key matrix. And there's a pin for the speaker. Now we'll go ahead and instantiate our objects. This is the object for the shift registers. We're using this library here for the shift registers. And then we instantiate our alphanumeric display. Again, we're using an Adafruit library for that. And then we will set up for our keypad. We have our button matrix pins right here. And then we have a character map for the buttons of the matrix. And then we will instantiate the keypad object. Then to keep track of what buttons are pressed, we have an additional multi-dimensional array here. The elements of this array are either going to be a 0, a 1, or a 5. And then later on, you'll see where they get summed. Here's an array of our pins for the shift register that's driving our LEDs. And we have a display buffer for our alphanumeric display. And then an array for the characters that can be displayed on the alphanumeric display. And then the columns for the alphanumeric display and the sum. In our setup, we set the pins for our register. And then next we set up our alphanumeric display. And then we create essentially it's an interrupt using the bead library event listener. So if a key is pressed, it will call this function, which is input event 2. Now in our loop, we call Soroban. In our Soroban function, we have beadpad.getKey. What that does is it listens for a key press event, and if it does get a key press, it will call one of these elements of our array, which is a character, and it will pass that on to input event 2, and then it gets the key. Then within our input event, we have our switch case. Every single one of these characters over here is accounted for in our switch case. For example, key 0 relates to this column and this row, and this is what will happen when it's pressed. So we have that for every single one of these buttons. So then after beadpad.getKey, we sum the beads. Let's go to sum beads. And sum beads, first we set all the columns, the column sum elements to 0, and then we have a loop that iterates through this what I call a bead register, which is a multi-dimensional array. So if it's a 0, 1, or 5, it will sum them here and then put the value into column sum. After that, we go to present result. In present result, first thing we do is make sure that whatever button is pressed, the LED is lit, and then also we present the value of column sum on our alphanumeric display. Now those are the main elements of our electronic Soroban program. Now let me show you what it does. So we have our main power switch, then we have a reset button. These toggle switches will reset whatever value is on these columns. Now let's see here. 1, 1, 2, 2, 3, 3, 4, 4. So we have 4 on our ones column here, which is our ones, tens, hundreds, thousands. And then what we'll do now, let's just hit the reset button on that column, and we'll go to 5. When this orange LED is lit, it's the same as saying this 5 bead is registered. So let's go 6, there's 6, 7, here's 7, 8, there's 8, 9, there's 9. So now we're going to go to 10. We'll unregister these beads and register that. So let's say I can either toggle to clear this column, or I can just push the buttons again and press the next one. Now we have 10, 11, 12, 13, 14, 14, and then 15. Let's go to, I can press 2 of them will light, 3 will light, 4. So let's say on our Soroban we want to press 4. This will illuminate all these LEDs, just like on the physical Soroban. We can slide the 4 and it slides all of them. Same as on here. That's what the that switch case was designed to do, to illuminate all the LEDs. So basically, it functions just like a regular Soroban, with the added option that I can pick it up and move it around, and the beads won't slide around on me, which was kind of why I wanted to make this, so I could pick it up and sit and fiddle with it without the beads sliding around. Also, it makes noises, pretty cool noises. There's 2 noises for each button, so when it's pressed, it makes a noise. When it's pressed again, it makes the inverse of that noise. I could add some more functionality here, but for now, this meets the goals of what I was trying to achieve. So tell me about the hex game.
Yes, so it has an AT-tiny 45, probably slightly overkill. I probably could have got away with an AT-tiny 25. Then we have 2 input shift registers, which read in these 8 switches as well as these status switches. And we have 2 output shift registers, which I have basically direct driving the LED module. So it's 7-segment display plus decimal points, so that's 8 bits. And then there's 3 of the 1, 2, 3, 1, 2, 3. So I use the upper 3 bits here to select what display you're drawing, and then I use the lowest 8 bits to actually draw each character. Then I also have another bit on this which goes to the speaker.
Cool.
So the speaker is actually everything fits within 16-bit word, and we're spying out to this at the same time we're spying in from this. Although it's not technically SPI, I bit banged it because I couldn't get the universal serial driver on this to work. So yeah, so it's got a little LiPo on there. I just made a casing for it, really simple in the back.
That's decent.
So it's got 2 modes. It's got demo mode, which is where you just click switches and it shows you the value in either hex or decimal. Anyway, so then if we switch it to game mode, it says high, 27 points, and then it actually has 2 different high scores, one for the decimal mode and one for the hex mode, because I realized, because originally you could switch it at any time, but I realized doing decimal is much harder than doing hex, trying to guess it. So I decided to kind of make it 2 different modes with 2 different high scores. So decimal is my new favorite because it's really hard. Well, let's show both. Okay, so high score for hex mode is 27. So it's going to show me a hex number, and I have to enter it in binary before time runs out. BA. Baracus, let's see, 6D, CF, so I had this thing where I had a hard time thinking in hex, And that's part of the reason I wanted to build this, was so I could train my brain to think in hex better. I mean, hex is pretty simple. There's 2 characters, so you've got the upper nibble and the lower nibble. A nibble is 4 bits. So in this case, it's C, C.
Yep.
Just gonna bounce out. So the real tough one is decimal mode, right?
Show me what you've got.
All right, let's see what I can do. Okay, 35, okay, that's easy. 32 plus 3. I mean, really, this is kind of a really good math tool, not just a computing tool. So the best way to do this is 255 minus 217, which would be, what, 38? So we go negative 38. See how that works?
Bravo.
You subtract the bits out. So 120 is close to 127, which I just accidentally typed in by trying to shift it over. 34 is easy, 32 plus 2. 221, okay, so let's go back up to 255, and 55 minus 21 is 34, so we go 34, boom.
Cool.
There's another high one, okay. I got it.
Well done, well done.
Yeah, like you can accidentally type something in. 50, oh shoot. Let's see, it's 48 plus 8 plus 1. So 207. Okay, so that's 55 minus 7, which is 48, which is 40. Oh crap. My brain's freezing up.
You got a timeout.
16?
207.
55 minus 7 is 48. So that would be...
32 and 16, right?
Hi.
Oh
it's
God,
15.
you're right, yeah.
Well, that's all the time we have for today. It was really fun making these games.
Have you ever made an electronic quiz game? Let us know in the Element 14 community at element14.com/TBHS. You can also go there to read about other upcoming episodes, builds, and special events. We'll quiz you next time. Stop moving for a second.
All right, I won't move at all. Unless I do. Or I'll attempt not to. I'll do my best to try and keep myself steady.
Really?
All right. In today's episode, we're working on the super glue gun.
What I want to do today is add the killer feature, which is the touch control auto stand. That's a winner-win at chicken dinner. We need a servo on this AT Tiny 20. So that is blah, 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 blah. Your mom's a worm gear.
I didn't know that.